Hi, I'm Trinity Henry-Jack. I'm a rising senior studying chemistry at California State University, Sacramento, and I had the opportunity of working under Dr. Baker this summer. For my project, I investigated what limits oyster success on shoreline structures in coastal Alabama. My primary goals this summer were to quantify oyster distribution among substrates, as well as identify the ideal intertidal zone, or the upper horizon, for oysters. This is the distinct level where oysters are abundant. And for my third goal, I examined the relationship between salinity and feeding rates of oyster drills. Cassosteria virginica, the eastern oyster, is a bivalve species that provides a plethora of ecological benefits to aquatic life and systems. These benefits include: they serve as natural breakwaters to prevent against ecological damage. They provide habitat for aquatic life, which helps to promote biodiversity. And they also serve as a filter in removing harmful pollutants from the water. Though they provide much benefit to aquatic systems, we have seen in the past years, since the 1950s, that the historic population of oysters in Mobile, Alabama has decreased more than 60%. This project this summer wanted to investigate ways that we can decrease that, or increase their population numbers. For my methodology of the experiment, I had two components: the spatial mapping and the snail predation experiment. For the spatial mapping, I used an RTK GPS to survey sites in areas of northwest Mobile Bay and into the Mississippi Sound. As you can see on this relative abundance map, as you start at the top near northwest, near Fowl River, we see that the markers indicate a relative abundance of the oysters seen at each site. As you go further up north Mobile Bay at Fowl River, Bay 1 and Bay 2, we saw 0 oysters. But as you go further down south, you see that the oysters number increases. And this is due to the salinity changes as you go further south down Mobile Bay. The water that runs off from the Mobile Tensile Delta is fresh, and when it meets the northern part of Gulf of Mexico, the water becomes more salty, which is the optimal salinity that oysters prefer to live in, as well as their predators, oyster drills. If we take a look at our spatial mapping results, we see that at the sites that we surveyed across, Northeast Point of Pines, Lightning Bay, Little Bay, Lightning Point, Coffee Island, Marsh Island, Bayfront Park, Alabama Port, the Causeway, and Dolphin Island, we see that the oysters live at a specific inundation duration of 50%. And for previous restoration projects that use reef blocks and reef balls for breakwaters, we can see that they're well below the duration, which is maybe preferable for some oysters, but we haven't seen much success with these restoration projects. For my second component of the experiment, the snail predation, I examined the behavioral patterns and the predation rates of snails, oyster drills, and different salinity gradients, those being 3, 5, 10, 15, and 20 PSU. If we take a look at our results from the predation experiment, we saw that the highest predation rates were recorded for 15 and 20 PSU, but the lowest predation rates were recorded for 5 and 10. 3 wasn't indicated on this data, or on this graph, because the snails in all of the 3 PSU buckets, let's take a step back. For the salinity treatments, there were 3 replicates, which gave us a total of 15 buckets. Coming back to our results, we see that for each of the buckets, I observed that for each of the 3 replicate buckets, the snails had osmotic stress, which made them inactive. And all of the oysters, or more than 15% of the oysters in all of the replicate buckets, had died and still contained their biomass, which can also let us know that oysters prefer not to live in that much fresh water in that amount of time. So what does this mean altogether? What can we pull from this? What can we pull is that these findings suggest a sweet spot for oyster success, both within the salinity gradient and vertically within the intertidal. Between physical extremes and predation pressures, this can limit oyster success. For future restoration projects, it would be best if breakwaters can be above the 50% inundation line to have oyster success. Thank you.